So you want to remove an element from a slice and go, but you're not too sure how. So there's a few ways you can go about it, but the most popular method I've seen online is by creating or slicing the current array and just kind of working around the array to preserve its order. Right now, I've just set up a new example where a new slice is assigned, and that's the way we remove the element. The remove index function essentially appends the current sliced array, which is going up to the index selected that you want to delete, and appending an array that goes after the index selected. So that's kind of like what these colons are representing. It's everything before the index, and then this one is everything after the index plus one. Got to increment the index plus one because it doesn't include the index. And that's essentially how we can get our array. But if you'll see here, if I run the example, you'll see that the new slice is 1, 2, 4. So we've successfully removed the element from the array. The index we selected was 2, of course, so that's 0, 1, 2. We want to remove the third element. But the problem is that the original array has been modified. Now, why the original array has been modified is because slices point to an array underneath the hood, and you'll see this in Effective Go, which is a Go tutorial I posted in the description as well. Essentially, what it states is that if you assign a slice to another slice, so for example, original slice to new slice, it'll actually still maintain the original slice as a pointer to the existing array underneath the hood. What that means is that if you modify anything in the new slice, such as, let's say, assign a new number, like new slice 0, 100, let's say, and we actually print that out, you'll see that the original slice has been changed to 100 as well, because that's the pointer under the hood. We're not just changing the new slice, we're changing the original slice. What we want to do instead to preserve the original slice in order is we want to create a new slice and return that instead. So that will point to a new array underneath the hood. All right, so I've commented out the old function, and now I have the new remove index function. And essentially, we are creating a new slice, and to this empty slice, we are appending the left side of the array relative to our index. Then we are appending that left side of our array to the right side of the array. So similar to the append operations we were seeing before, except this is all operating on the new slice, which starts as empty before. So let's print that out and see what happens. The new slice is 100, 2, and 4. So we've successfully removed the third element, and we've reassigned the element, or the first element, to 100. And the original slice maintains its order because the original slice is still pointing to the old array. This by hand is a much less destructive operation, but nonetheless, if you intend to dispose of the original slice anyway and just feed it to the garbage collector, this may not matter too much for you. But I think that this is a much more cleaner solution for keeping a stable program. I've referenced a Stack Overflow post, which I put in the description for you to check out as well if you want to see a different perspective.